As NASA increases the durations for space mission, countermeasures to physiological problems become more and more important.
Hi, I'm Jamila Siamwala and I will discuss some of the physiological problems on the International Space Station and the possible countermeasures to maintain astronauts' health and well-being. Let me introduce fluid shifts to you. When we are on Earth, the body fluids and the blood moves towards our feet because of gravity. However, when we leave Earth's gravity, the body fluids and the blood tends to move upwards towards our brain. This results in facial puffiness. This might also result in high intracranial pressure, which might lead to headaches and may cause vision impairment. So how do we fix this problem? Let me talk to Dr. Huggins and see if he can come up with a solution.
I think one of the possible countermeasures is to use a lower body negative pressure chamber, such as this, and we're trying it on Jackie right now. Here we have a lower body negative pressure chamber on a tilt table, and the reason why we use the tilt table is to shift the blood and the tissue fluids from the lower body down to the hip.
The lower body negative pressure uses suction to create a negative pressure. The negative pressure can provide gravity-like stress. The LBNP chamber is tightly sealed at the waist. When the subject is tilted head down, the subject experiences a headward fluid shift, pretty much similar to what happens in space. We are using the photoplethysmography device, also called as the PPG device, to measure the bone circulatory flow. We place the PPG probe on the tibia of the subject's leg. When the subject is tilted head down, the bone blood flow increases in the legs. And when we switch on the lower body negative pressure, the bone blood flow comes back to supine levels.
We now know that the lower body negative pressure can bring down the intracranial pressure and the bone blood flow to normal levels. But the crew members are on the International Space Station for longer periods, so we need more studies to find out what will happen if we use long-term lower body negative pressure. Our Gravity Sucks team here is looking to answer questions such as using an ultrasonography to distinguish between the large artery and a microcirculatory flow, tonometer to measure the intraocular pressure, compartment syndrome with lower body positive pressure, and ground reaction force using the force transducing sensor strips. We are also participating in rodent sharing program and we're looking at bone and vascular changes in space mice.
I would love to describe more about this work and to share our past 6 years research experience. Thank you for your consideration.